Hi, my name is Behrang Fakharian. I am a registered architect with the Ontario Association of Architects in Canada, and I'm also an associated member of the UMR Geography City Research Center at Paris Sorbonne University. Today, I will present Teaching Retro-Innovation Methodology as a Holistic Approach to Bioclimatic Design. This article is a culmination of my research and teaching activities as an adjunct associate professor between 2013 and 2016 in two different architecture schools in France. My pedagogic approach was formed progressively through my interactions with my students, other professors, researchers, and sessional interactions with craftsmen and builders. It is also derived from my architectural practice, vision, and the synergy that I've tried to generate between constraints and realities of architectural practice and critical thinking and scientific life of academic environments. This point of view helped me to explore how can we increase students' involvement in community development, and how can we blend practitioners, contractors, craftsmen into academic areas to enhance constructive dialogues, not only between industry and academia, but also between different generations, disciplines, and professional orientations. My pedagogic approach begins at École Spéciale d'Architecture in Paris, with a research-based course that I designed in response to emergence of urban ecosystems, ecology, and eco-friendly architecture. It was basically a series of ideas connected to the interrelation between design, technology, and environment. It investigated buildings in their local culture, local resources, and local climate. Our goal was to study passive and hybrid heating and cooling techniques both in vernacular communities and in contemporary energy-efficient buildings. Each session was about a specific social and climate condition. We overviewed different typologies of vernacular architecture to learn how they were developed progressively based on their local resources, regional cultural life, and native geoclimatic conditions. In other words, why are they integrally connected to their specific time, region, and society? What are the modalities of their passive thermal devices? What can we learn from these vernacular knowledge and apply in the contemporary context with complex issues of program, globalization, and technology? This was a key question that let us explore the transfer of technique from the past into a different temporal, spatial, and social context. It's a process that may involve adopting innovative methods and creative solutions. This is why we call it retro-innovation. At some point it becomes an exercise to understand that passive heating and cooling devices, in contrast to active thermal machines, are usually a livable space of the building that can be misunderstood, transformed, or destroyed by inhabitants. So here we emphasize the holistic approach of bioclimatic design, how a specific building component performs in the whole system. We try to examine the context of each case study to have a wider framework of sustainability in terms of social, cultural, economic, and technological parameters. and not be limited to energy data and performance. Our case studies originated from multiple sources, including the selected bibliographies, contemporary projects, and our personal research trips and investigations around the world. Teaching this in the cosmopolitan city like Paris was interesting, as the students visited or came from different geographic and cultural backgrounds. This course also explored a variety of building techniques, details, and assemblies with local resources and materials like timber, earth, stone, bamboo, and other plants. And this is how we developed our second research-based course covering the use of low-carbon, geosourced, and bio-based building materials, questioning their properties, life cycle, constructability, as well as new progress in technologies. Our intention was to rethink the construction history, not only by means of major scientific or technological inventions, but also in terms of knowledge and skills formed gradually in vernacular and indigenous communities, and also in contemporary informal settlements. We asked how some of these techniques have continued with the arrival of new industrial products, or why some of them have been abandoned. What is the place of geosourced building materials today? How can they contribute to the culturally transforming age? How have these products been received or understood among users, clients, consultants, and contractors? What is the place of manual craft and experimental fabrication in the construction industry today? What is the role of digital technologies in this process? Asking these last few questions and doing research on different construction systems led us to organize a series of workshops and led to hands-on experience with geosourced and recycled materials. The school itself is situated in dense urban area of Paris city center. Despite the lack of space and materials, we managed to work in the school courtyard on some complex assemblies like dry stone construction. These courses and workshops were further expanded to project-based learning through design projects at the master level. My students' work were founded on research and problem-solving methodologies, questioning the architecture as an urban or rural ecosystem both in micro and macro scales. From the very beginning, they were invited to generate site analyses considering physical or social conditions, and also by means of technical heritage and available resources. The result of this approach were expressed into a set of dynamic sketches, models, and narratives to study contextual constraints and opportunities of the site. Alongside the functional, aesthetic, and social concerns of the project, each student was encouraged to promote innovative construction systems and passive or hybrid environmental control devices into their project. They applied the experience and lessons from their previous research and workshops to generate and incorporate new hybrid materials and devices into their design solutions, reflecting today's ecological and economic challenges. The progress of the students' work was reviewed and analyzed through interactive and collaborative debates to choose and form a series of integrated technologies, constituting a specific system for each project. This is based on the interrelation between the site and its natural, social, and urban environments. This exercise generated a critical point of view on the relationship between technique, time, and society. It allowed them to improve their design approach and vision by cultural and technical imagination alongside with spatial and diagrammatic conceptualization. In the meanwhile, we started thinking about the architectural practice today. How is the daily life of designers in architectural firms around us, by investigating their methods of production and also their office culture. Through this exercise, we noticed that most of the firms have similar interior organization and project delivery methods using digital technology on a daily basis. Two important issues are raised here. First is the separation of design and construction phases. The fact that usually the creativity happens before the construction process. And the second is the difference of scale between monitors, screens, or models which architects use in the process of design on one hand, and built environments as the final product on the other hand. This becomes interesting when we compare it with the manner that master builders used to work in the past, where they used to be the designer, manager, and builder at the same time. That's how my students and I were questioning the process of design by studying alternative methods of architectural production. We started looking at some firms around the world who try to merge the process of design, innovation, and technical investigations into the act of construction. Contrary to conventional design practice, these designers work actively with models, mock-ups, and craftsmen in studios or job sites. They have hands-on experience. They are involved in both design and construction. However, these studios work usually on rural projects or in informal settlements like refugee camps, or small-scale design-build projects in urban areas, or occasionally on some iconic buildings. But one important question here for us as designers who would like to live and work in metropolitan cities is how this design approach would find its place in dense urban area, where we are facing fundamental challenges such as limited access to geosource materials, code compliance, contracts and legislations, lack of craftsmen, laborers, and builders specializing in a specific renewable material or building systems. Also, social image and understanding of these materials or devices. So, here are the questions. How can we reinvent the process of design and architectural production for the next generation of eco-friendly designers? How can we establish a holistic mechanism of material experimentation, coping with the process of digital technology and industrial production? I have found a part of my response to these questions through my teaching and curriculum development at the Grenoble School of Architecture. There was a meaningful exchange of the technical curriculum with the design studios thanks to the in-house research centers like Créateur and Culture Constructive. There was also sufficient material, physical, and spatial facilities to do so. In the large basement of the school, and also in Grand Atelier, which is a shared learning campus for sustainable construction close by at Auvergne-Rhône-Alpes. This is where students can experiment design through the act of making. They were able to build their ideas on actual scale and make use of renewable materials. When ideas, devices, tools, and materials come together, students can explore full-scale design problems. Both digital and manual skills are essential to celebrate the craft of making. And this craft of making as a representation of the process and the product. In a cooperative and team-based approach, a dynamic learning environment can happen by the interaction with multidisciplinary professors and experienced instructors, as well as by mutual learning and informal transfer of knowledge between students. This type of program is also integrated in the curriculum of other schools of architecture around the world. They promote a team of observers, explorers, and fabricators, and involve active hands-on experience in design and construction. Some of the resulting projects were small buildings, landscapes, or shelters which serve as amenities for their local and even global communities. Today, as I reflect on my academic future, I will promote a team-based teaching and research platform concentrating on eco-friendly design and construction solutions for dense urban fabric of metropolitan cities where the complexity of social, technical, and environmental conditions requires a holistic and multidisciplinary approach. In this manner, the teaching module would be a design, build, and craft studio, or even a new master program that would be a place for both research-based and project-based learnings. A social environment where we establish a close and thematic collaboration with researchers, practitioners, builders, and craftsmen. The students' design exercises would vary, ranging from the component part to the overall ecology of the built environment. In such a collaborative and participative setting, we can rethink and make bioclimatic architecture not only as a technical product, but also as a cultural phenomenon.